these issues we're receiving. So, and just by one way of example, there's been a number of different studies that looking at sort of dense urban core high-rise office buildings in transit-connected places, downtown Chicago, inside the loop, Manhattan, San Francisco. When you have a high-rise building that is accessible via lots of different modes of transit for which the urban infrastructure discourages the use of single-occupant vehicles. If you take that building and you analyze the total carbon footprint, you can see that the bulk of the energy that is used, the bulk of the carbon that is emitted as a result of that project is the direct energy that's used by the building in its electricity and heating and cooling systems. When you take that building, that same building, and you unplug it from a dense urban core, transit-connected community, you stick it in the middle of a green field, and you surround it with acres and acres of parking lot, there are a number of different studies that show that the carbon intensity of that new building that you built in a non-transit connected community is actually dominated by single-occupant vehicle travel to and from the building. So the commuting energy associated with that project can take it from being almost no commuting energy associated directly with that project to more than 50% of the total carbon associated with the project. So when we're looking at these things, and we're looking at things like density and diverse uses, that's what we're trying to encourage project teams to think about, and try to encourage project teams to think about adjacent development, infill development, those types of activities. I'm going to breeze through a couple of these. If there's anybody who has any questions about any specific concept that's up here, don't hesitate to ask. So we still have retained the Sustainable Sites credit category. It's just what is appropriate for this discussion going through. So it's basically the stuff that was in the Sustainable Sites credit category that is actually site related. So when you look at these, you see construction activity pollution prevention, so that's erosion and sedimentation control, that type of thing. Open space, rainwater management, heat island reduction, light pollution reduction. So the things that happen that are in the control of the design team on this, within the project boundaries, right? You can't necessarily control whether or not you are building over top of a metro station or a subway station, but you can change the location of the building. You can't really, that's the only way that you can control that aspect of it. But when you're looking at rainwater management, you have a much more direct control over those outcomes. Does that make sense? So let's talk about rainwater management for a minute. And I'm going to come back to this slide. So we care about rainwater management for a variety of different reasons. How many of you guys know what a combined sewer is? Right. All right. So for those of you who don't know what a combined sewer is, in a lot of large cities, the storm sewer, which is the sewer that captures all of the rainwater that falls in the hardscape and channels it away from, flooding up the city, eventually is combined with the sanitary sewer, which is what happens when you flush or take a shower or wash your hands or do dishes or whatever. Right? So those two streams come together somewhere and they go to a centralized treatment plant down pipe from wherever you're looking. In heavy rain events, what happens is the wastewater treatment plant is overwhelmed by the amount of rainwater that has fallen and has been conveyed to it, and it overwhelms the treatment facility's capacity to deal with that much water. So there's a couple of different ways that cities have responded to this challenge, because when the wastewater treatment plant is overwhelmed, the operator has a couple of different choices. They can back up the whole system and basically flood out the upstream, the up-pipe reality, and which comes at a cost, right? So sewer backups and standing water that otherwise would have been drained into storm sewers, or they can open the gates and just let everything flow into the receiving water body, untreated, right? So you end up with dumping, diluted, but raw sewage into your receiving water bodies, which has a whole host of problems, which we care about because it has a direct impact on biodiversity of the receiving water body. If you dump your shit into the river, it's not going to be good for the people. It's not going to be good for the downstream aquatic life, let alone the people that are there. So there's a human health impact. There's issues associated with climate change because we're not, the issues associated with climate change and green economy are both kind of wrapped up together because the large-scale city mitigation strategy is to invest billions of dollars in concrete tunnels to put all this water until it can be treated on a regular basis. So concrete is the most energy-intensive, carbon-intensive, ubiquitous building material that we use. And our solution to these problems that we have with combined sewers is to invest in huge concrete pipes, to basically detention pipes, to mitigate our impact downstream, or just delay our ability to do that. So when you look at cities like Chicago, they're investing in these big pipes. And Washington, D.C. is doing it, Boston's doing it, New York's doing it, because they have an immediate problem. But the other thing that Chicago has understood is that if they can mitigate the amount of rainfall that is incident on a site and keep it on site for a period of time, they have the ability to minimize the amount of pipe, big, huge storm surge capacity that they would invest in. So who can think of one idea that would enable you to take otherwise hardscape and potentially retain water on site for a period of time?
Retention pond?
A retention pond would work. Wetland, a constructed wetland. Cisterns would work, right? So then what can you do with the water once you collect it? You can reuse it, you can flush toilets, you can irrigate plants. What Chicago has done, and sort of taken a lead, is they've invested heavily in green roof technology, right? So you have this ability to again, understanding that all of these things are connected is a critical aspect to one of these things. So we talked about cisterns, we talked about, which is gives you the ability to be much more engaged in a discussion of water efficiency, right? Because we flush with potable water, right? We wash our hands, I guess that's a bad example. We flush and wash our cars and irrigate our lawns with potable water. Water that is drinkable, is a prime resource. We are investing millions of dollars in infrastructure that is designed to deliver healthy drinking water for our use, and we are essentially wasting it because we have not integrated other technologies such as rainwater capture, filtration, and using that rainwater for sewage conveyance or for irrigation. So there's a lot of different things that from a water efficiency perspective are interrelated across the sustainable sites section and the water section of LEED V4. But I want to point out that this is the first place that you'll see one of the major structural changes, one of the major technical changes that we've made to LEED V4. This is the first place that you see new credit requirements and prerequisite requirements around metering and subsystem metering of both the whole building water use and individual systems within the building. There is an axiom that you will probably hear if you haven't already heard it already. You can't manage what you don't measure, right? And you'd be astonished by the number of buildings on this campus that don't have a building level water meter, right? Because it's all paid by one central bill, there's no incentive to do that. But the reality is that if you have 100 buildings connected to one master meter, You don't have any visibility into whether or not one of the buildings, or 10 of the buildings, or 50 of the buildings are using water efficiently or not. So LEED v4 requires the installation of building level water meters and gives additional incentive for subsystem metering across the board. We've also added new credits that deal with processed water usage, specifically and for some buildings, most importantly, focused on cooling tower water use. Again, cooling tower water use can be, for certain buildings in certain climates, the #1 point source of water use. And for the most part, the typical building will use potable water to run through their cooling tower. Again, this is another application that we can, if we invest in cisterns and invest in systems that allow for us to recapture and reclaim and reuse that water, this is another place we can use captured on-site water. From an energy and atmosphere perspective, LEED is upping the bar